If you recall, in the lesson about CPU memory, we said that this memory is composed of four main sections: load memory, work memory, system memory, and retentive memory. We used the system memory for addressing while programming. In this lesson, we want to learn how to use the system memory environment for addressing. Well, system memory itself consists of 5 parts: PII, PIQ, bit memory, timers, and counters. PII, or Process Image Inputs, is the environment we can use to do the addressing for PLC inputs. PIQ, or Process Image Outputs, is the environment we can use to do the addressing for the PLC outputs. When we are programming, the bit memory environment is for bit memory addressing, the timers environment is for timers addressing, and the counters environment is for counters addressing. In this lesson, we will learn how to do addressing for inputs, outputs, and bit memories. In the next lesson, we will learn how to do addressing for timers and counters. We can divide each part of the system memory into rows with 8 sections. Each of these rows is called a byte, and each one of the sections that the bytes are made from is called a bit. Therefore, each row is a byte, and each byte has 8 bits. These bits run from bit number 0 to bit number 7. In other words, the first bit of each byte is bit 0, and the last one is bit 7. Okay, now let's go after the addressing and see how we can use this system memory for addressing. We have 4 methods for addressing in PLC programming, which we utilize depending on our needs. The first method is bit addressing, meaning that the addressing is based on 1 bit of the system memory. In this method, we introduce 1 bit from the system memory as an address to the CPU. In order to write an address using the bit method, we need to follow a particular format. For instance, if we want to use a bit number 2 from byte number 0 in the PII environment as an address in a program, first we need to put the letter I to show that this address is related to the PII and the inputs. Then we put the desired byte number, which is 0 here. Then we put a dot and the bit number, which is 2 here. Therefore, IO2 represents bit number 2 from byte 0 in PII. Now, let's consider another address, like I246, as an example. Here, the letter I tells us that this address is related to the PII environment. 24 means byte number 24 within this environment, and 6 means bit number 6 from this byte. Therefore, we can recognize from the specificity of an address exactly what part of the system memory this address is related to. We use this method of addressing for outputs and bit memories as well. The difference is that, in order to show the output address, we use the letter Q, and for bit memories, we use the letter M. For instance, Q81 means bit number 1 from byte 8 in the PIQ environment. Or, for example, M257 means bit number 7 from byte number 25 in the bit memory environment. Therefore, in bit addressing, first comes one of the letters, I, Q, or M, then the byte number, then the bit number. Okay, as you have seen, the bit address has a limitation. We always only have 8 bits in each byte, numbered 0 to 7. But are there any limitations for the bytes as well? In other words, when we enter IO2 as an address, can we also have, for instance, I252 and use the 250th byte of the PII as well? In order to answer this question, when we are connected to the actual or virtual PLC, we can come to the Semantic Manager environment in our project structure and right-click on the CPU, choose PLC, and select the Module Information option. opening up its corresponding window. In this window, when we choose the Performance Data tab, we see that it specifies the capacities of different sections of the system memory in the address area box for us. For instance, it tells us that, considering the 1024-bit capacity for the PII, you can assign the input addresses from I00 up to I127-7. This means that the last byte we can use for the input address is byte number 127. Therefore, we can't use an address like I252 in here. We use the same method for the outputs and memory bits. In other words, as you see in here, it tells us that the output addresses can be selected from Q00 to Q127-7. We can choose the address of the bit memories from M00 to M16383-7. However, note that these numbers are different based on the type of CPU. If we had another CPU instead of this 315-2DP, the capacity of different sections of the system memory would vary depending on the type of CPU. The second method we can use for addressing is byte addressing. In this method, instead of introducing a bit as an address, we consider one whole byte as an address. For example, IB4 means the entire byte number 4 in the PII environment, or QB19 means the entire byte number 19 in the PIQ environment, or MB12 means the entire byte number 12 in bit memory environment. Hence, in this type of addressing, the entire byte of the memory is used as an address in the program. When we put 2 bytes of the memory near one another, a 16-bit memory space is made, which we call word. In the third method of addressing, we consider a word of the memory as an address. To do so, just like before, we enter one of the letters, I, Q, or M. Then, we enter the letter W in order to show that it is a word from the memory environment that we are considering, and then we write the number of the word. For instance, if we place 2 next to IW for the inputs, we are considering bytes number 2 and 3 as an address. Or if we put 4 in here, we are considering the bytes number 4 and 5 from the PII environment as an address. In order to do output and bit memories addressing, we also use the same method. For example, QW8 means bytes number 8 and 9 in the PIQ environment. Or MW12 means bytes numbers 12 and 13 in the bit memory environment. The point in addressing using the word method is that we should select the word number such that there won't be an overlap between the addresses. What does this address overlap mean? I've already explained. If we consider IW4 as an address, we have selected bytes number 4 and 5 from the PII environment. Now, if we use the IW5 address in any other section of the program, we have used bytes number 5 and 6 in PII as well. Therefore, in this case, we have used byte number 5 for 2 different addresses. In other words, the IW4 and IW5 addresses are overlapping at byte number 5, and this results in an error in programming. What should we do in order to prevent the address overlap? In this situation, PLC programmers usually use even number addresses for word addressing from the beginning of programming. For example, IWO, IW2, IW4, etc. In addressing with this method, our addresses always need to be 2 bytes apart from each other. As you can see from this example, there won't be any overlap between the addresses anymore. Now, if we put 2 words from the memory together, a double word is formed as a result. The last method for addressing is addressing by means of a double word. In this method, just like the other methods, first we put one of the letters I, Q, or M. Then we enter the letter D, which represents a double word, and at the end, we enter the number for the desired double word. For instance, if we want to address the inputs using this method, we can use ID0, ID4, and ID8. We can have the same method for addressing outputs and bit memories as well. This method of addressing as well, the most important point to consider is address overlapping. In order to prevent address overlapping in this method, we need to select addresses that are 4 bytes apart. For example, if we have MD24 as an address, and we want to prevent overlapping, we need to select MD28 as the next address and MD32 as the next address. In this lesson, we learned different methods of input, output, and bit memory addressing. In the next lesson, we will go after addressing timers and counters.